Let's start with GFG problem of the day. This is absolutely no, this is not. This is the today's daily problem. Make array elements unique. You have been given an array which contains some elements. They can be unique or not unique. Or let's say you have been given n elements. So task is to want minimum number of increments. So how you are making the array unique? You are doing some increments. You are adding into some number, right? Required to make all the elements array unique. So that is no value in the array should occur more than once. So currently, like 122, value 2 is occurring more than once, and basically the 2 has frequency 2, so you want to make everyone unique, so you will increment this 2 by plan, so this will become 1 2 3 in just one operation. So that's what you need to do, and pretty simple question. So for example, 1 1 2 3, you have to do increment this 1, but then if you do increment the 1, it will become 2. The 2 is already present. Now you will see, okay, now 2 are 2 2s, so you will increment 1 2 to become it 3. Now the two threes are there, so you will increment one of the 3 to make it 4. So at last you will have 1 2 3 4. Okay, that is the thing, I think. Yeah, that's about it. Now how you can do it, there are multiple ways to do it. Obviously you can check how many numbers are there, and how you can make numbers which are not equal. You can apply some memorization logic. What I did, I simply see like how I did. Let's talk about that. So for example, double one two three, right? Okay, now let's start with that. Level 1, 2, 3, you have 1. So you will say, in my map, I have not seen 1. So basically, I'm keeping a map to track how many elements which I have seen. So I have not seen 1 before this. So I'll say 1 is unique, right? Now, when the next one comes, so I'll say, okay, I have seen 1, 1. So you cannot be the unique person. So increment something to it. So let's say we increment 1. Now you can become 2. So I'll say, okay, I have not seen 2. So it's good for me. Now you see again 2. Okay, 2 is coming, so I need to increment it something so that it has not come on before. So 2 is common before, so I'll increment it to 3. I'll not check whether the 3 is after there, so it will become same elements. Then that will I handle on the when I reach the next 3. Currently 3 is good for me because I have not seen 3 in the past, right? So 3 is good. Now I'll say 3. Okay, I have 3 in the past, so you have to increment it, so make it 4. So that's how I return the same array 1 2 3 4 and make same number of increments, which is 3. So that is the whole logic for this problem. So that's why I'm saying this is pretty simple problem. So for int I is equal to 0, don't even need to do that. Auto I in arr, you just need to see if your m dot count exists for I. You're gonna do key, okay, I need some increments, right? Z plus plus, you change this value to I. You are saying, okay, is I plus 1 is good? He'll say, okay, is it good or not? So that based on that, after that you'll fix some value for I. Okay, now you fix that. Okay, 2 is good my value because I have not seen 2 before, so 2 is my good value, and you'll do, okay, I've seen 2 once before, like just due to this. Now when you see the next 2, it will say, okay, you already have a 2, so I have to increment something. So it's the either way. Okay, so you can do this, like you can make this 1 directly to 4 because 2 is present. You cannot make it 3, so you can directly make it 4, something like that. But for that you need to keep track of all the after elements, so that's why that's more of a tedious. But you can just say that you have not seen 2 before that, so let's make it 2. If there comes 2 after this, I don't know whether 2 is after this or not, but if it comes, I'll increment that and reach the same number, like 3. So this is the basically, you can also, if you take more examples, you can prove it by just logic that it will always give the minimum number of you know uh, minimum number of increments. That's what you will get by increment this directly to 4. So both the things will give you minimum number of increments. So this is the pretty easy logic to, without just seeing anything of the future, you can just make the decision based on the past of the map. So map dot count and z plus plus and return z. Z is not being made, so let's make Z as long as they say. And I think it should be fine. Let's try this. I have a custom input also. Maybe it's, yeah, it's I plus plus and semicolon. You can use some example test case. Working. Oh, okay, not working. Why not working? Hmm. When this R is equal to 0, Z plus plus, I plus plus, map of I is equal to, okay, what's happening? You'll do Z plus plus. Why I'm doing mi plus plus down there? Because in every way you will increment it, whether it is present before or not. You have to increment it. Why is it giving 7 as output? I have to see that. So for 3, what we can do, we can just check out the value for z after each. Do we need to sort it? I don't think we need to sort it. So he'll say 0, okay, he'll say 1, okay, he'll say 2 because I've seen this. Now you have made this to something like 4, you have made this to something like 5. For this 4, you'll see, okay, I've seen the 4. So you have seen the 4. Okay, what's happening? So Z is getting incremented every time. So you need one operation, you need two operation for this. For this, you need three operation, or you just need one operation, 4 to 5. Because 5 you have seen, so you need two operation for this. While, oh, not if, while. This is while. I told you the thing, but I did if. So if is not working, while will be working, because while this doesn't becomes equal to, count doesn't equal to become 1, up till that you have to increment it. It's not about if, like I'm just because like 1 and 2 you have seen this, so you'll increment it until the point then it doesn't get repeated. So for example, it was, what I'm saying. So if it was 4 ones, right, so you will increment. First one does not need to be incremented because there's nothing, so this will become 2. So you say incrementation is equal to 1. You'll say, okay, now 1, let's try to increment it 2, but you have seen that also. So one more incrementation is required, so you will increment it to 2. 3. So now 3 does not have any counter. So while, it's important, while. So that's why you'll stop at 3, because 3 doesn't have any count. So m of 3 would be plus plus, and still you start from 1. You'll say 2 having a count while loop is running. So it will just keep on running till 4. Something like that will happen, and you'll get 1 plus 2 plus 3. That's 6 in this case, I think. Yeah, that should be fine. Let's try to sum this up quickly. And it's working pretty fine. So that's about it. Yeah, today's daily problem of GFG. Simple one. Map and just checking whether you have seen this number or not, and increment the value, and get to the point where this number is not seen by using this while loop, and then increment that number in the map as well, so that you can tell the, whenever you see the next same number, you can say that, okay, I need some update, I need some incrementation. Do that and return your Z. Today's daily problem 11 1 23. Okay guys, bye.